Let's get today's math lesson. So it's a follow-on from yesterday. Yesterday's was kind of horrible, but this is much better. Okay, so this is the lesson from the textbook. We'll do it just like we would at school on the smartboard. Okay, so I'll talk you through it. See if you can answer it before I show you the answers. Okay, so let's do the first one together. Calculate the theoretical probability of each event when rolling a die. Okay, first thing to understand, it's a regular die. It has 6 sides. Okay, so each probability with one roll will be out of 6. So question 3a, when it's written P with something in the brackets, that's basically saying what's the probability of rolling a 6. Okay, that's how the mathematics looks in terms of asking a probability question. You don't want that as a word problem, you want it to look just like that. So the probability of getting a 6 would be 1 out of 6, which is 17%. I'm rounding everything. I want whole percentages because when we're talking about a dice roll, like 0.7% or 0.6%, don't need that. Okay, don't really need that at all, so just give me a whole percentage. See if you can do B and C. So the probability of getting an even number and the probability of getting a number less than 3. So pause it and give it a try. Let's take it up. So the B, the probability of the number being even is 3 out of 6 because 2, 4, and 6 are even numbers. So we have 50%. Okay, let's look at this. The probability of getting less than a 3. So it's not including 3, it's less than a 3. So if I think about a die, 1 and 2 are less than 3. That's only 2 of the outcomes out of 6. 2 out of 6 is 33%. Okay. This question's a bit of a beast. So Elaine spun this spinner 80 times and graphed her results. So take a look. So look at where my cursor is. So there's the spinner. It has 10 sections. She spun it 80 times, and these are her results. So that's the number of the spinner, and that's how often it happens. So you can see in 80 spins, she rolled the number 1 6 times, the number 2 6 times, the number 3 8 times, and so on and so forth. So look at how much work I did before I even read the question. A, the probability of spinning a 3 is 8 out of 80 or 1 out of 10. Which numbers had greater experimental probabilities? So remember, not theoretical, experimental. So we're looking at this. As soon as we've done an experiment, as soon as we've spun the spinner, it's experimental. Okay, so you probably figured out the numbers bigger than 3 were 7, 8, 9, and 10. B, pause this and give it a try. What is the theoretical probability of spinning each number? Okay, so pause it and see what you get. You should find that the probability of each number is 1 out of 10. In terms of probability, they don't do a good job of scaffolding how this should look. If I have a probability of 1 out of 10, but I'm doing 80 tries, do you remember doing these? Okay. So if my probability, if I did this 80 times, I would expect 1 out of 10 to be equal to 8 out of 80. That's the theoretical probability. So you'd be looking at 10%. So how many of each number would you expect? I mean, the question doesn't ask that, but in this unit it could. You'd take your 1 out of 10 or your 10%, it's the same thing. How many 7s would we expect to get? Well, Getting a number 7 is 1 out of 10. If I'm doing 80 spins, I take 10% of it. I expect to get 8. Okay, I know that wasn't the question, but that's where this kind of math is going. Okay. Okay, look at this one. So, calculate the theoretical probability of each event using one of the 4 items below. Okay, so look at the 4 items. We have a coin, so straight away you should think 1 out of 2. We got a spinner, you should think 1 out of 5. This is a 4-sided die, and I know you might not ever have seen this. So I'm just helping you. That's a 4-sided die. There is a deck of cards. Okay. In terms of a deck of cards, there are 52 cards. There are 4 different suits. That's spades, clubs. Clubs, spades, diamonds, and hearts. There are 13 of each of them. Okay, so it's good to memorize that kind of stuff. So, question A, tossing a tail. B, spinning a 4. C, drawing a black card. D, rolling an even number. E, spinning an odd number. F, drawing a red card less than 9. And G, rolling a number greater than 1. So pause this and see if you can try A through G. Let's take them up. So, tossing a tail. Well, it's a coin. So, tail would be 1 out of 2, 50%. Question B, spinning a 4. There are 5 sections. There is 1 4, 20%. If you put 4 out of 5, that's the trap. Okay, just remember, spinning a 4 is one event. Okay, it's not 4 outcomes, it's one of the outcomes. It's very important to make that clear. C, drawing a black card. Well, there are 26 black cards out of 52 cards total, 50%. D, rolling an even number. Well, it's a funky die. It's a 4-sided die. So 2 out of 4 gives me 50%. E, spinning an odd number. Well, my odd numbers are 1, 3, and 5. So I've got 3 out of 5, which is 60%. F, drawing a red card less than 9. So I've got ace through 8 of diamonds. I've got ace through 8 of hearts. I've got 16 out of 52, which is 31%. And G, rolling a number greater than 1. Well, again, it's a 4-sided dice, so bigger than 1. I've got 2, 3, and 4, so 75%. And let's finish it up with this. I'll read the question, see if you can do all 3 without any help. There are 10 red marbles and 6 green marbles in a bag. Alex will choose 1 marble without looking. Calculate these theoretical probabilities. So A, the probability of it being green. B, the probability of it being purple. C, the probability of it being red or green. Okay, so the first one. What we need to understand, we have to add. We got to find out how many marbles are in that bag. There are 16. Okay, so A, probability of green. We have 6 out of 16, which is 38%. B is a trick question because purple is not one of our colors. Okay, so anytime we have something that doesn't appear, it is 0%. And finally, C, the probability of red or green. Well, they're all red or green, so it's 16 out of 16, which is 100%. And finally, why might experimental probability be different from theoretical probability? Take a minute to see if you can answer that on your page before we take it up. If you're blank, this is kind of how I approached it. Unless you do thousands of trials, you see different numbers play out. It happens all the time when you take a coin and you flip 3 heads in a row. That shouldn't happen, but it does. If I put it into a sporting realm, Steph Curry, he's a career 93% free throw shooter from the line. Sometimes he misses twice in a row. If you shoot 93%, you should hit greater than 9 out of 10. Okay, so he should very rarely miss one. Sometimes he misses 2 in a row. Okay, when he takes 100 free throws, sometimes he hits 100 in a row. And that's all part of probability. But if you look at his career, it all kind of evens out. You need thousands of trials until your probabilities kind of line up. Okay, that's our lesson for today.